Bismillahirrahmanirrahim. Rabbi zidni ilma. Raise your words, not voice. It's the rain that goes fast, not thunder. Assalamu alaikum. My name is Dr. Sadia Rafi, and today my topic of presentation is Japanese encephalitis. The synonyms for this are Japanese B encephalitis, arbovirus B encephalitis, mosquito-borne encephalitis, Russian Ottoman encephalitis, brain fever, summer encephalitis. Arboviruses. During the past few years, a large number of arthropod-borne viruses, which are known as arboviruses, have been isolated from sick persons, animals, and arthropods throughout the world. Arthropod-borne viruses are defined as viruses which are maintained in nature principally or to an important extent through biological transmission between susceptible vertebrates host by hematophagous arthropods. They multiply the tissue of arthropods and passed on to the new vertebrates by the bite of arthropod after a period of extrinsic incubation. It has two groups, Group A and Group B. Group A involves alpha viruses, which lead to syphilis and chikungunya, and Group B includes flaviviruses, which leads to dengue, KFD, Japanese encephalitis, and West Nile. Japanese encephalitis is a mosquito-borne encephalitis caused by Group B arboviruses, flavivirus, and transmitted by clusine mosquitoes. It is a zoonotic disease mainly infecting animals and incidentally man. If we go see the history, the first epidemic was in 1870 in Japan. At that time, it was called summer encephalitis. Then in 1924, great epidemic in Japan again. 6,125 human cases were there and 797 deaths were reported. Then the next in 1935, first isolated from the fatal human encephalitis case. In 1938, isolated from Culex triancanus Trianchorhynchus mosquito, which is a type of species of the mosquito. Then in 1940 to 78, disease spread by epidemics in China, Korea, and India. 1983, immunization in South Korea started as early as at the age of 3. Endemic areas even start at early age. In 1983 to 1987, vaccine available in United States on investigational basis. Prevalence, most important global cause of arbovirus encephalitis with more than 50,000 cases and 15,000 deaths reported each year. Only about 1 in 250 Japanese encephalitis infection result in symptomatic illness. Primarily affects children 1 to 15 years of age. If unrecognized, mortality is up to 30%. Incubation period is 5 to 14 days. Geographical distribution. It is a leading cause of viral encephalitis in Asia and occurs in almost 24 Asian and Western Pacific countries. Largely as a result of immunization, its incidence has been declining in Japan, the Korean Peninsula, and in some regions of China. But the disease increasingly reported from Bangladesh, India, Nepal, Pakistan, Northern Thailand, and Vietnam. Transmission occurs principally in rural agriculture locations where flooding irrigation is practiced. Transmission is seasonal, mainly related to the rainy season in Southeast Asia region. As we can see in the map, the maroon color is showing the risk areas for this disease, and the light peach font color is showing with no risk of the Japanese encephalitis. And this maroon area, you can see India, Burma, Thailand, South Korea, North Korea, Japan, a little bit portion, Brunei, Malaysia, Indonesia are involved. First discovered and originally restricted to Japan, now large-scale epidemics occurs in China and India and other parts of the Asia. Flavivirus transmitted by Culex mosquitoes. The virus is maintained in nature in a transmission cycle involving mosquitoes, birds, and pigs. Most human infections are subclinical. They are apparent in clinical cases in 300 to 1 ratio. In clinical cases, a life-threatening encephalitis occurs. The disease is usually diagnosed by serology. No specific therapy is available. Single Culex has a flight range of 20 kilometers. All local control measures will fail. An effective vaccine is available. This is very important feature in this, that this mosquito has a range of 20 kilometers. So only by the local preventive measures, we won't be able to control this disease. So we have to increase the area of the coverage. Japanese encephalitis viral infection, it is caused by a flavivirus, a single-stranded RNA virus. It is transmitted by the bite of the Culex tri-10 mosquito. The virus multiplies at the site of the bite and in regional lymph nodes before viremia develops. Viremia can lead to inflammatory changes in the heart, lungs, livers, and reticuloendothelial system. Case fatality rate ranges from 0.3% to 60% and depends upon the population and on the age. The surge in the cases, the black color is showing the cases and red dots are showing the deaths. In 2015, there were 8 cases and 1 death. In 16, 32 cases, 5 deaths. 2017, 30 cases, 1 death. In 2018, 108 cases and 2 deaths. After this, there is no data available on the net. So we have seen that it is spreaded by the mosquito and it affects mostly children below the age of 15 years. About 25% of the affected children die. Among the survivors, about 30% to 40% children suffer from the physical and mental impairment. There is no specific antiviral medicine available for this, and cases are managed symptomatically. Epidemiological determinants. Agent. The virus is spherical 40 to 60 nanometer in diameter, contains a positive sense single-stranded RNA. Several viruses in this group are related. Host. Horses are the primary affected domestic animals of Japanese encephalitis, though essentially a dead-end host. Other equids, donkeys are also susceptible. Pigs act as amplifiers. What it means? Amplifiers of the virus producing high viremias, which infects mosquito vectors. The natural maintenance reservoir for this virus are birds of the family Aridae, herons, and egrets. These you can see the egrets. These are the birds, water birds, and the pond herons. Two prominent hosts are the herons act as a reservoir host and the pigs as amplifier host. So I have made the difference. Herons are natural reservoirs of the disease and pigs are amplifier hosts because they multiply, they increase the viremia to that much level and the mosquito bites and gets the infection. Human infection tangentials and infections are spread when the infection mosquitoes reach high density. It is the life cycle. You can see that in the natural life cycle, it's the waterfall, then the mosquito waterfall, it could move, so moves like this, and it involves the pigs as well. But when this infected mosquito bites the human, then it leads to the disease in the humans. Mosquito vector. Culex mosquitoes, notably Culex tritinire C. vishnae, and C. gelidus, along with some Anopheles, have been incubated as a vector of this. Among these two have been implicated as the most important vector in South India as well. These mosquitoes generally breed in irrigated rice fields, shallow ditches, and pools. The rice fields are probably the most important breeding places. These mosquitoes are zoophilic, feeding primarily on vertebrate host. Female mosquitoes get infected after feeding on a viremic host, and after 9 to 12 days incubation period, they can transmit the virus to the other hosts. These are the different types of the Culex and the Anopheles mosquito. Breeding habitats are the rice fields, mainly shallow pools and ditches. Transmission. It is a vector-borne disease and zoonotic cycle. It means the virus in a transmission cycle between mosquitoes and pigs slash water birds. Mainly it is the Culex species and the reservoir amplifying hosts are the pigs, bats, and every wading birds, possibly reptiles and amphibians. Mhm. Incidental hosts are horses and humans and others. You can see the cycle animal, arthropod, man cycle. It shows the pig and the mosquito and it's being transferred to the man. Then again, the natural cycle of this disease, amplifying cycle and the humans. The mosquito bites and picks up the virus. Infected mosquito bites animal viruses, and this cycle goes on. And when this infected virus bites a human, non-host animals who are vulnerable to pass on the virus. Pathogenesis. Virus enters the body by the bite of the insect, which is a vector mosquito. After multiplication, the local and regional lymph nodes, viremia develops. Virus is transported to the target organ, which is the brain, through blood. Virus proliferates and damages the neuronal tissue and elicits nervous Manifestations. Clinical manifestations are its incubation period is 60 to 16 days. It has three stages. The prodromal stage, there is a prodromal fever, headache, nausea, diarrhea, vomiting, and myalgia may last for several days. Then the second is acute encephalitis stage. This may be followed by a spectrum of neurological disease ranging from mild confusion to agitation to overt coma. And the late stage of sequelae, two-thirds of the patient have seizures. There, it is more common in children, while headache and meningism are more common in adults. Neurological damage, tremors and other involuntary movements are common. Mutism have been described as a presenting system, so has a system of acute flaccid paralysis. Fever resolves by the second week and chorioathetosis and or extrapyramidal symptoms develop as the other neurological symptoms disappear. Case fatality rate varies between 20 to 40%, but it may reach 58% over higher in children. 30 to 50% of people that survive the infection develops paralysis, brain damage, or other serious permanent sequelae. Average period between the onset of illness and death is about 9 days. And if the mother is in utero infection possibly occurs, then there is abortion of the fetus. So it is a picture of a 5-year-old boy with Japanese encephalitis. Levels of prevention. Primary prevention, as we know, health education and specific protection. Prevention is preventive measures include the vector control because basically it spreads by the infected mosquitoes. So vector control, eliminate mosquito breeding areas, adult and larva control. And in this cycle, as we know, the pigs are also involved, so locating pigs away from the human dwellings. The sign, the countries where they harbor or take care of the pigs, they should be away from the human residential area or living areas. Then there should be the vaccination, vaccine of the equine and swine. Equine means the vaccination of the horses, and the swine means the vaccination of the pigs. Then the humans should have the vaccination. Then personal protective measures, avoid prime mosquito R's and use of repellent containing DEET. Vaccination. Currently, three types of vaccines of Japanese encephalitis are in use. First is mouse brain derived inactivated vaccine based on either Nakayama or Beijing strain of Japanese encephalitis virus. Second is cell culture derived inactivated virus vaccine based on Beijing P3 strain. And third is cell culture derived live attenuated vaccine based on SA14, 14-2 strains of Japanese encephalitis. The mouse brain derived vaccine, it is usually given children at 1 to 3 years of the age. Two primary doses are 4 weeks apart. Booster is given after 1 year until the age of 10 to 15 years. And its quantity is 0.5 to 1 ml subcutaneously. Second is cell culture live attenuated vaccine. It is early good childhood protection by single dose followed by a single booster given at the interval of 1 year. The number of doses is less in live attenuated rather than mouse drive. Then for the travelers, more than 1 years of age, three primary doses are recommended for the travelers are at the day of 0, 7 and 28. And those travelers who are going to the areas where there's epidemic of the Japanese encephalitis or those areas which are endemic for it. Safety of current Japanese encephalitis vaccination side effects includes local tenderness or mild systemic symptoms in 10 to 30% of the cases. No neurological event is seen. Infrequent allergic reaction is seen in adult travelers. None of the reactions were severe or life-threatening. Case control study in Australia identified case reaction risk if excessive alcohol consumption in 48 hours after vaccination. Research priorities include facilitate implementation of attenuated vaccine in unvaccinated population in endemic areas, develop improved vaccine, identify risk factors for progression to symptomatic encephalitis and viral persistence, describe clinical features of Japanese encephalitis in AIDS and determine its potential as an opportunistic infection. Then the secondary prevention includes a diagnosis, the isolation of virus from blood, CSF, cerebrosinus fluid or tissue, detection of arbovirus specific RNA again in blood, CSF or in tissue. Serology by ELISA, IgM captured enzyme-linked immunoassay ELISA of serum or CSF is the standard diagnostic test. Sensitivity is nearly 100% when both serum and CSF are tested. False negative may result if the samples are tested too early, as in the first week of illness. New IgM dot enzyme immunoassays for CSF and serum are portable and simple tests that can be used in the field. Compared with ELISA as the gold standard, the sensitivity and specificity are around 98 and 99% respectively. Then the treatment, there is no specific treatment for this, only symptomatic treatment. So it's a summary. Again, the whole thing which I have told you, that the the infected mosquito bites is a natural life cycle of it, where patient gets symptoms, severe headache, vomiting, fever, and one in the 250 cases result in a severe illness, disorientation, coma, seizure, spastic paralysis, and even death. And death rate is on 30%. Regarding global and national updates, there's a surveillance program by WHO of Japanese encephalitis. The rationale and objective of surveillance is that they establish Japanese encephalitis epidemiology, including defining at-risk population and estimating its burden in the community, determine geographical distribution, then provide information to inform its vaccination policy, then evaluate vaccine impact and effectiveness after introduction. Then in the Pakistan, the International Association for Medical Assistance to Travelers has this. The report suggests that the risk is present in the lower Indus Valley and the Karachi area. Transmission occurs from June to January. And the vaccination is recommended for the person traveling extensively in rural areas, long-term travelers, and person on work assignments in endemic areas. And same, if you go to the site, the recommended travel vaccination of the Pakistan is also for the Japanese encephalitis, but in the case of the person is traveling. As such, there is no data regarding Japanese encephalitis is available on net for as regarded to Pakistan, and the figures which were available internationally, they were up to 2018, which I've told already. Was the recent advantage of the Japanese encephalitis vaccine. It is an activated viral cell culture derived Japanese encephalitis vaccine manufactured as Izaro, is the only vaccine licensed and available in United States. This vaccine was approved in March 2009 for use in people aged 17 years and older, and in May 2013 for use in children 2 months through 16 years of the age. Other vaccines are manufactured, used in other countries, but are not licensed for use in the United States. So initially it was for the people who are age 17 years, but in 2013, it is started from 2 months of the age till 16 years. It was also given in two-dose series with the doses spaced 20 days apart. Adults aged 18 to 65 years can get the second dose as early as 7 days after the first dose. The last dose should be given at least 1 week before travel. It is the important thing in it. The booster dose, which is called the third dose, should be given if a person has received the two-dose primary vaccination series 1 year or more previously. There is a continued risk for Japanese encephalitis virus infection or potential for re-exposure. Like if person is going through some traveling some area which is endemic for there's epidemic, then he or she would have the third dose. Now coming towards the multiple choice questions. Japanese encephalitis is a vector-borne viral encephalitis, high transmission rate, has an incubation period of 5 to 6 days, it's associated with a rate of approximately 10%.
Alpha.
Yes,
Alpha.
it's A. Japanese encephalitis vaccine should be given to those who are in endemic or epidemic area, be given to laboratory staff, not be given to those who had a confirmed anaphylactic serious systemic reaction to the previous dose, not to be given to those who had a confirmed anaphylactic reaction to a component of the vaccine.
Alpha. Alpha.
Alpha, yes. Okay. Yes, I have already mentioned it because it should be given to the person in routine. In most of the country, we don't have the routine